Welcome to part 5 of your Unit 1.8 Acids, Bases and Salts topic. We're getting there. This video looks at the reactions of acids with metal carbonates and metal hydrogen carbonates. So we're starting on page 19. So when an acid reacts with a metal carbonate or a metal hydrogen carbonate, we have another general equation to learn. So what we find is, as always, with these reactions we form a salt. So when a metal carbonate reacts with an acid, we form a salt. Same with the metal hydrogen carbonate. It forms a salt when it reacts with acid, but our side products are different than the previous reactions. Well, one of them is the same as the last one, which is water. In both of these reactions we get water as a side product, but there's another one. And the clue is from this carbon, part of your carbonate or hydrogen carbonate. Our other product is actually carbon dioxide. So you need to be familiar with the general equation for these reactions, and that will help you determine the products if you were asked to write an equation for these reactions. So you can see that a metal carbonate and a metal hydrogen carbonate react in the same way with acid, and that is to produce a salt, water and carbon dioxide. Again, our salt is named in exactly the same way. First part of the name from the metal, and the metal carbonate in this example, but we ignore the carbonate parts and just take the name of the metal. Second part of the name comes from the acid, and it changes just as before, so sulfuric to sulfate, hydrochloric to chloride and nitric to nitrate. We have to be careful when writing balanced symbol equations for these reactions. As you can see here, I've got copper carbonate. So I need to know the formula of my carbonate if I'm going to write equations for these types of reactions. So carbonate, if you look on the back of your periodic table, it appears as CO3. So that's 1 carbon, 3 oxygens, and it has a charge of 2-. So when I'm doing my swap and drop, I will write down carbonate, and it will always be the second part of the name. So we'll put our valency up here. It's carbonate with a valency of 2. Hydrogen carbonate is very similar. What we do is we just add a hydrogen at the start, HCO3. But this time, technically we've added an H+ ion on, so we raise the charge by 1 essentially. So if we have, essentially what we've done is we've taken H+ and reacted it with our carbonate. So if we just add those together, we get HCO3 as our formula. But think about the charge now. We've got plus minus 2. So it's 1 plus minus 2 is a total of 1-. So hydrogen carbonate has the formula of HCO3 minus. So when we are doing our swap and drop, we would write down the formula of HCO3, and then it has a valency of 1. Okay, so its valency is different than the carbonate ion because of that extra hydrogen ion that it has present. Those formulas you need to be familiar with, but they will always be on the back of your periodic table, but we need to be able to know how to use them. Over on page 20, we have an observations table again, where we're going to look at the reaction of copper carbonate and sulfuric acid, and then sodium hydrogen carbonate and nitric acid. You can begin to fill in your products column already based on our general equation and naming your salts. And the next part of the video is going to show you these reactions, but be writing the observations in as you go along. So we're now looking at the reaction of a metal carbonate with acid, and as we looked at with the general equation, we are going to produce a salt, as with all the other reactions, but our side products are going to be water and carbon dioxide. So first of all, I'm going to do the reaction of sulfuric acid, which is in this boiling tube. You can see I then have a sidearm with a delivery tube into another boiling tube. That's because we're going to test the gas given off. And this time we said the gas was carbon dioxide. How we test for carbon dioxide is using lime water. So we're going to bubble the gas given off through our lime water, and we'll see what happens. So I am going to add in my copper carbonate, which you can see is a green powder. I'm going to add that into my colourless acid, and then I'm going to stopper it as quickly as I can to get all the carbon dioxide gas into the lime water. So watch what happens if we add that in. Stopper the boiling tube so you can see the gas is passing through to the lime water. So if you were asked for the observations of the reaction, you would be looking at the observations of what's happening in this boiling tube. But the test that's happening in my other boiling tube is to confirm that my gas is carbon dioxide. So hopefully you can see that the lime water is changing from colourless to a milky colour. You can see the white precipitate is what we call it. But the observation of when lime water and when carbon dioxide is passed through lime water is that it changes from colourless to milky, and that confirms that the gas given off is carbon dioxide. Have a look now what's happened in our other boiling tube where the reaction was happening. You can see that the colourless solution of the acid has now changed to blue, and that's because think about what your salt is. It's copper sulfate, copper from the copper carbonate, sulfate from the sulfuric acid, and copper is blue in solution. You can see that my green solid has disappeared, and obviously your observation of bubbles of gas that we have confirmed are carbon dioxide, and finally that heat is released. If I feel around the walls of the boiling tube, I can see that heat has been released. So those are the observations you need to know for that, and you need to know that the test for carbon dioxide is by passing it through lime water. Lime water will change from colourless to milky. So before we move on to the next reaction, let's check you got all those observations filled in. Okay, so we saw fizzing, or bubbles of gas produced, or effervescence, and that was due to carbon dioxide being produced in this reaction. We saw that our green solid of copper carbonate disappears, and even without seeing this in an exam you could work that out, because you know that copper carbonate, or you should know that copper carbonate is green. And as it reacts, it will be used up, and therefore we describe it as disappearing. You will know that your solution of acid is colourless, and because we are forming copper sulfate, you should know that that's blue in solution, so our solution changes from colourless, how it originally started with the acid, to blue. And that's because we have formed copper sulfate. Copper in solution is blue. And then finally, some heat will have been released. Let's think about what our products there were. So you have your metal carbonate, or your hydrogen carbonate, reacting with acid to produce a salt, water and carbon dioxide. It's so important that you know these general equations, and they'll help you write specific equations for specific reactions. Okay, so our products are a salt, first of all. How we name the salt: first name from the metal, and second name from the acid. So the first name is copper, second name from the acid, but it changes from sulfuric to sulfate. Our other products are just our general side products that we get every time: water and carbon dioxide. Once you've filled those in, we will go on and look at the reaction of sodium hydrogen carbonate with nitric acid. So we're now looking at an example of the reaction of a metal hydrogen carbonate with acid. And we can see from the general equation that it reacts in the same way as a metal carbonate. So it produces a salt, water and carbon dioxide. So we would expect to see similar observations as well, but there's one that's quite different with this. And that's because we're using sodium hydrogen carbonate and we're reacting that with nitric acid. Your observations are filled in on page 20, but compare your observations with what we actually see happening here. So the difference in this reaction is that the temperature will actually drop when this reaction takes place. So you can see my thermometer is in my solution. It's at about 15 degrees at the minute. I'm going to add my sodium hydrogen carbonate in, and hopefully we should see that the temperature actually drops. You can remember with most of the other reactions, they gave out heat and became very hot. But in this reaction, we expect to see the opposite. So if I add a spatula full of sodium hydrogen carbonate, you can see the fizzing occurs immediately. And that's because carbon dioxide gas is being given off. I'm not going to test that with lime water in this case because I want to focus more on the temperature. So you can see the temperature is starting to drop. All my sodium hydrogen carbonate, the white solid, has disappeared, forming a colourless solution. That's another observation. We'll add a little bit more to see if we can see this effect of the temperature any more. So if you watch the thermometer carefully, you should see the temperature drop. It's down now at about 14. Give it a gentle stir, we can see that it's dropping very gradually, remembering that we're doing this on a test tube scale. So it's not going to be a massive difference. I try a little bit more. You can see the temperature's now down at 13. And dropping down a little bit further as my sodium hydrogen carbonate reacts. Add a tiny bit more. And you can see my temperature's gone right down to 12 degrees now. The more we add in, the further it would drop. But that's an important difference to remember in this reaction, that when sodium hydrogen carbonate reacts with an acid, the temperature falls. So you can see your observations are already written in for you on page 20, but that's an important difference to remember in this reaction. So most reactions of acids will release heat, but this one actually takes in heat from the surrounding, and so we will see the temperature falls. Where the other reactions were called exothermic, they gave out heat. This is an endothermic reaction. It takes in heat from the surroundings and the temperature as a result falls. And you need to know that that's an exception to these reactions, that sodium hydrogen carbonate, when it reacts with an acid, the temperature will fall. Let's have a think about our products. Well, going back to our general equation, the same thing applies for hydrogen carbonates as well. When metal carbonates or hydrogen carbonates react with acid, we get a salt, water and carbon dioxide. The salt has two names, remember. First part of the name from the metal, second part of the name from the acid. You'll be sick of me saying this by now, but hopefully you'll get it by the end of it. So our first name is sodium. Second name is going to be nitrate from our nitric acid. And our other products are water and carbon dioxide, according to our general equation. Again, we could have tested that carbon dioxide using lime water. If we bubble carbon dioxide through lime water, it turns from colourless to milky, as we saw with our copper carbonate and sulfuric acid reaction. Now we need to be able to write equations for these reactions. You may feel confident in doing these yourself, in which case go ahead and then check you've got the right answer. If not, I'll talk you through the first couple of examples. So we've got copper carbonate and sulfuric acid first of all. We can just write our word equation using the terms we've already decided. So if I make this a bit smaller, we can see from our table our reactants and our products. So the first reactant is our copper carbonate. So copper to carbonate. The 2 just tells me the valency of the copper since it's in the transition metal block. Copper carbonate plus sulfuric acid. Okay, and then my products are in this box here. So we've got copper sulfate, and it'll be copper 2 sulfate again, and water and carbon dioxide. Okay, now time to write my equation for this. And we actually wrote the equation for this when we were doing our equations topic. Let's have a look at how we would do that. Well, copper carbonate, first of all, we need to use swap and drop for it. So copper is Cu with a valency of 2. I can tell that from the number inside the brackets. Carbonate, as we discussed in the previous page, is CO3 with a valency of 2. If you can't remember that, look to the back of your periodic table. Look at my ratio of my valencies. They're 2 to 2, so I can cancel that down to 1 to 1. Then when I swap and drop my 1s, I'm going to ignore them, so I can just write my formula as CuCO3. Sulfuric acid is H2SO4. Copper sulfate, then I need to use my swap and drop for it as well. Again, copper is Cu with a valency of 2. Sulfate you should know by now. It's on the back of your periodic table as SO4 2-, so I need to write down my SO4 as my formula and then use the 2- charge for my valency, which is going to be 2. That cancels down to 1 to 1, and then when I swap and drop, I get CuSO4 plus water, which is H2O, plus carbon dioxide, which is CO2. What you should do now is make your list of all the atoms that you have. Count up how many you have of each. But I'm not going to do that now, as I know that this equation is already balanced. I have the same number of each atom on either side of the equation, but that is something you should check in the exam. But this equation is already balanced. This is the equation now for the other reaction we did of sodium hydrogen carbonate with nitric acid. Again, try and give it a go yourself and then watch to see if you've done it correctly. So again, we could get our word equation from our observations table because we've already determined our products. So it's sodium hydrogen carbonate with nitric acid. Remember general equation, salt, water and carbon dioxide. Our salt is going to be sodium nitrate. And then our side products are water and carbon dioxide. Try your best to fit it all in so we can write our balance symbol equation directly underneath. But if you do run out of room, just make sure you keep your products on the right hand side of the arrow and your reactants on the left. Okay, sodium hydrogen carbonate, I'm going to have to do swap and drop with it. It looks like it's more complicated, but it's no more complicated than with sulfate or nitrate or carbonate. Just take the first part of your name, which is sodium, Na, work out its valency, it's group 1, so it has a valency of 1. Hydrogen carbonate, no more complicated than carbonate or sulfate. Just remember its formula is HCO3. Or you don't necessarily have to remember it. It's on the back of your periodic table. But it has a charge of minus, which means its valency is 1. Can't cancel those down at all. They're already in their simplest form. So when we swap and drop, we'll end up ignoring the 1s. And so we'll end up with sodium hydrogen carbonate as NaHCO3. As simple as that. Nitric acid, you need to be familiar with its formula. It's HNO3. That's reacting to give me sodium nitrate. Again, I need to do my swap and drop with this. Sodium is Na with a valency of 1 because it's in group 1. Nitrate appears in the back of your periodic table as NO3-. So I need to write down my formula first of all, which is NO3. And then I use my minus sign for the valency, which is 1. Swap and drop those valencies. And you've got NaNO3. And you've got water, and you've got carbon dioxide. Again, at this stage, you should have made your list of elements, counted up your atoms. But if you did that, you would see again that this equation is already balanced, so I don't need to do anything to it. But you should always check by making your list of elements and counting up the number of atoms. And checking that there are the same number of atoms of each element on the left-hand side as there are on the right-hand side. Okay, for the next one, calcium hydrogen carbonate and sulfuric acid, especially if you haven't done so already, give this a go yourself, pause the video, and then replay when you're finished to see how you got on. If you're nervous about putting it straight into your book, take a spare page and do it on that, and then we will check through. So when writing the word equation for any of these type of reactions, or when asked to write the balanced symbol equation, you should always start with the word equation anyway. But what I need to do first of all is work out what my products are. So that's where the general equation always comes in handy. So I've written that above. So our metal hydrogen carbonate in this case is calcium hydrogen carbonate. My acid is sulfuric acid, and I might just write it like this so I can fit it all in the left hand side. Our salt then, well, the first part of the name of the salt comes from my metal, which is calcium. Second part from the acid, which is sulfuric acid, and it changes its ending to sulfate. Calcium sulfate plus water plus carbon dioxide. Again, that's a bit of a squeeze. Okay, calcium hydrogen carbonate. We need to be really careful with this. So let's split it up into two colours. Calcium is Ca. It's in group 2, so it has a valency of 2. Hydrogen carbonate, no different than before. It's HCO3 with a valency of 1. But you can see I'm going to be swapping a 2 down. So I actually need to put my hydrogen carbonate in brackets. So swap and drop those. My 1's going to end up disappearing. So I can just write Ca rather than 1 after the Ca. My hydrogen carbonate has stayed in brackets. And remember to carry through your 3 from the formula. So it's HCO3. And then what goes outside the brackets? The little 2 that I swapped down from my calcium. So that's why we need brackets there. So that 2 can go outside the brackets. Sulfuric acid is H2SO4. Calcium sulfate, again split it up. Calcium is Ca with a valency of 2. Sulfate is SO4, also with a valency of 2. Those valencies are going to cancel down to 1 to 1. Then when we swap and drop those, we're going to end up ignoring our 1s, so it's just CaSO4. Don't need brackets this time because I didn't swap a number down. And then finally, we have plus water plus, make this a tiny bit smaller, plus our carbon dioxide. This equation is not balanced, so I need to make the list of elements on either side of the equation. So let's identify them first of all and separate them all out. So I've got calcium, I've got hydrogen, I've got carbon, I've got oxygen, and then I've got sulfur. Copy that list on the right hand side as well. Calcium, hydrogen, carbon, oxygen and sulfur. Let's count up the elements now. On the left I have just 1 calcium because that little green 2 only applies to what's inside the brackets, not the calcium as well. That little 2 multiplies everything in the bracket by 2. So you can see I've got 1 hydrogen in the bracket times by 2. So that's 2 hydrogens within calcium hydrogen carbonate. Then I've got 2 in sulfuric acid as well. So that's a total of 4 hydrogens. Carbons now, I have 1 carbon inside my brackets, but that's multiplied by 2. So I have a total of 2 carbons. Oxygens then, I've got 3 oxygens in my bracket, times by 2 is 6, plus my 4 from sulfuric acid, which is a total of 10 oxygens. And then sulfurs, I just have the 1 in sulfuric acid. Over on the right hand side is a little bit easier now. Calciums, I just have 1 of. Hydrogens, I have 2. Carbons, I have 1. Oxygens, I have 4 in my calcium sulfate, 1 in my water, and 2 in my carbon dioxide, and that's a total of 7. And then just your 1 sulfur. So you can see it is my hydrogen, carbon and oxygen that are the problem. And the oxygens look a little bit complicated to balance. So let's start with either the carbon or the hydrogen. Probably the carbon first of all, because you can see I've got 2 on the left, but only 1 on the right. How am I going to get 2 on the right? Well, remember, you can only put numbers in front of a whole formula at this stage. If you need to draw your boxes in, please do that. But I'm going to get 2 carbons on the right by putting a 2 in front of my carbon dioxide. That's now going to give me 2 carbons, and if I count up my oxygens again, I've got 4 in my calcium sulfate, 1 in my water, and now 2 times 2, which is 4 in the carbon dioxide. That's 4 plus 1 plus 4, which is 9. So you can still see I'm 1 short. But let's fix our hydrogens first of all, because they're slightly easier to see. So I've got 4 on the left and 2 on the right. So again, I get 4 on the right by putting a 2 in front of my water. Think how many hydrogens now you have. You've got 4, 2 times by 2. Oxygens, you've got 4 in your calcium sulfate, now 2 in water, that's 6, plus 4 in your carbon dioxide. That's a total of 10 oxygens. So now your equation is balanced. So you need to be able to write equations for metal carbonates and metal hydrogen carbonates reacting with acids. You could even give yourself a few different combinations like magnesium carbonate and nitric acid, and then sodium hydrogen carbonate and hydrochloric acid, and so on. Give yourself different combinations of metal carbonates and different acids to practice these equations. And then finally, in this part of the topic, we just can look at the test for carbon dioxide, so just as we did with the test for hydrogen as well. So if you want to test a gas to see if it is carbon dioxide, what you do is you bubble that gas through lime water, and the lime water changes from colourless to milky. This is the most important part of your test. So it's lime water turns from colourless to milky. But just as we had with our hydrogen pop test, it's important that you state what you actually do and then what the positive result is. So what do you do, and then the positive result. So what you actually do is you bubble the gas through a solution of lime water. I'll highlight that in green. Gas is passed through a solution of lime water. Okay, so that's what you do. And then your result is that your lime water turns from colourless to milky. That's your positive result. So you need to state those two things if asked how to test a gas for lime water in the exam. So that's us finished the reaction of carbonates and hydrogen carbonates. Again, practice those equations. And then once you're ready, you can move on to part 6, which is the final part of this topic.